I hope that now I am audible to all of you and visible to all of you. I hope that I am audible to all of you and visible to all of you. The live chat is on now. Please respond through the live chat whether I am audible or visible properly or not. Okay, so we are discussing the address bus, data bus, control and status signal, power supply and frequency signal, externally initiated signal, and serial input output ports before the technical problem occurred in my system. Actually, my system has restarted unwantedly, that's why this problem has occurred. Okay, so without wasting any time, so we first go to the address bus section. Address, now we are discussing address and data bus system. Address bus are denoted by A0 to A7 and A8 to A15. A0 to A7 are known as lower order address bus. They are responsible for transmitting lower order addresses. Data and higher order address bus are A8 to A15. They are unidirectional in nature. They are responsible for transmitting the higher order address. For example 9050, if it is an address, then lower order address bus will transmit 50, and higher order address bus A8 to A15 shall transmit the address 90. So this is all about the basically the address bus that we are basically talking about. The address bus, so we are observing that there are two parts of the address bus. One is A0 to A7, another one is A8 to A15. So these 8 signal lines are address bus, that is A8 to A15, which is known as higher order address bus. They are unidirectional in nature and they are used to address the peripherals or memory locations. They are used to address the peripherals or memory location. What do you mean by peripheral? Peripheral may be some input or output devices. Next is AD0 to AD7. AD0 to AD7 are known as bidirectional address data multiplex bus. What do you mean by multiplex? Multiplex means time shared. That means when time permits, these buses can act as an address bus. So whenever microprocessor wants to inform the memory about the address, this bus that is AD0 to AD7 act as A0 to A7. Similarly, when data need to be transferred, then D0 to D7, this data bus is used. They are multiplexed or time shared. That means to say that during the time when time permits, A0 to A7 will act as address bus, and when time permits, D0 to D7 will act as data bus. There are total 8 data bus in our system in 8085 microprocessor, that is D0 to D7. They are bidirectional in nature. Why bidirectional? Because data bus means sometimes memory may need to send data to processor, sometimes microprocessor may need to transfer the result to memory. That is why data bus is bidirectional. As because data bus is bidirectional, if we make address data multiplex bus bidirectional, then only address can be sent or data can be sent in one way, but data cannot be transmitted from other way. So generally these lines are demultiplexed using latch. We are about to use a latch. What is the purpose of latch? The purpose of latch is to demultiplex. That means is to filter out A0 to A7 from AD0 to AD7. So during the execution of the instruction, these lines, that means AD0 to AD7 lines, carry the address bits during early part. That means first clock cycle. Then during the late parts of the execution, they carry the 8-bit data. That is demultiplexing, which we shall discuss later. Am I properly audible to all of you? Am I properly visible to all of you? Whether my screen is properly visible to all of you, please reply if it is. Is there any buffering problem or any other problem you are facing? I don't think so. So let us move to the next slide. After address bus and data bus, our next point of discussion is control and status signal. We have two control signal, RD bar and WR bar. RD bar and WR bar. We have two status control signal. RD bar and WR bar both are active control low signal. That is because there is a bar over there. RD bar and WR bar, because there is a bar over there, they are both active control low signal. With the help of RD bar, we can read data from a memory or from an IO, and with the help of WR bar, we can write a data from memory or IO. Next, we have three status signal, IO slash M bar, S1 and S0. What is IO slash M bar? With the help of IO slash M bar, we can able to perform memory operation or IO operation. When memory operation is performed when IO slash M bar is 0, and when IO operation is performed when IO slash M bar is 1. M bar, that means when M for memory, IO for input output, that means IO operation. So when IO operation is performed, it should be 1. If it is 1, then memory 1 bar, that means memory operation becomes 0. Now if 0, that means IO is 0, that means no IO operation. And M bar, that means what is the value of M now? 0. So 0 bar means 1, that means memory operation will be performed. Okay, so there are three status signal related to the pin description of Intel 8085. How this status signal are operating? How this status signal are operating? Look at this flow. This chart is saying that how the status signal are operating. We can perform memory operation or IO operation. There are three memory operation: opcode fetch, memory read, memory write. There are three IO operation: IO read, IO write, and interrupt acknowledgement. when 011 opcode fetch operation is performed. What is opcode? What is opcode fetch? You have already learned in computer architecture and organization. What is memory read? When the microprocessor is reading some data from a memory address, that is read. When IO/M bar is 0, S1 is 1, S0 is 0, then memory read operation is performed. We are using the control signal RD bar in that case. Memory write. What is memory write? When microprocessor is transmitting some data into the memory, then the memory write operation is performed. When it is performed, 00001 when the value of the status signal. Which control signal is used for memory write? WR bar, because it's for writing. Next is IO operation. First IO operation is IO read. IO read operation, the status signal values are 110. Which control signal we use? As because it is a reading operation, we are using WRD bar. Next is IO write. For IO write, now I think the problem has resolved. Now I think the problem has resolved. Now what is in case of the interrupt acknowledgement, we are observing that the value is 111 and we are using INTA bar. When INTA bar is 0, then we are using the interrupt acknowledgement. What is INTA? INTA stands for interrupt, A for acknowledgement. Bar means it is an active low signal. That means if INTA bar is 0, we are acknowledging the interrupt. Whenever an interrupt occur, it will first request the microprocessor to grant it. Microprocessor can do two types of thing. Either it can ignore the interrupt or it may accept the interrupt. If it is accept or acknowledge the interrupt, then INTA bar value should be 0. Another special signal is there in our microprocessor which is known as ALE. Look at that, ALE. ALE stands for address latch enabled signal. It goes high during the first clock cycle of the machine cycle and enables 8 LSBs of the address to get latch. What does it mean? ALE is address latch enable. This signal is basically activating a latch which is outside the microprocessor, and this latch is capable of demultiplexing the address data multiplex bus. That means when microprocessor needs to transfer a memory address, to the memory address to a memory location, then AD0 to AD7 should be demultiplexed, and we need to filter out D0 to D7 from it, and we need A0 to A7 only. That is why we use address latch enable line or signal. Our next category is power supply and frequency signal. Our next category is power supply frequency signal. There are two power supply signal, VCC which basically supplies past 5 volt and VSS which supplies the ground reference. We have 3 frequency signals, X1, X2. These two are frequency signal. X1 and X2, these pins are used for providing the clock frequency to the microprocessor. I repeat, X1 and X2, these two pins are used for providing the clock frequency for the microprocessor. Microprocessor, as I said earlier, has a crystal oscillator circuitry that generates the frequency. Frequency generated here is internally divided by 2 channels. So as we all know that basic operating timing frequency of microprocessor is 3 megahertz. So crystal oscillator is generating 6 megahertz frequency, which is divided into two channel. Each channel, one channel is x1, another channel is x2. x1 is transmitting 3 megahertz, x2 is transmitting 3 megahertz. Next is clock. Clock is basically used for system and other devices to inform the system which operation to be performed, how it should be performed, what should be the time for performing an operation, when an operation should be started, when an operation to be ended, when memory address need to be transferred, when data need to be read, when data need to be write, etc., etc. These to be operated or calculated by clock signal. It is an output signal, that means microprocessor will generate this clock out signal to other devices to inform them to be ready for the data transmission operation. Our next category is externally initiated signal. Externally initiated signal is basically of three types. One is interrupt related signal. Microprocessor has 5 interrupt signal trap. Trap is a pin through which any non-maskable interrupt interrupt device may request the microprocessor. What is non-maskable? An interrupt which cannot be ignored by the microprocessor is known as non-maskable interrupt. Then we have a RST 7.5, RST 6.5 and RST 5.5, which are basically restart type of interrupt. RST stands for restart. 7.5, 6.5, 5.5 are different variation of restart type of interrupt. Then we have INTR. INT stands for interrupt, R for request. So any device which are maskable or non-maskable can request the microprocessor with the help of INTR signal. Upon receiving the interrupt request coming from those pins, microprocessor may have two options. Either it can ignore it or it can accept it. If it accepts the signal, then with the help of INTA bar, it will send a zero value to that particular device which is generating the interrupt. If it is ignoring the interrupt, then with the help of INTA bar, it is sending 1 to the interrupt generating device. Our next category of externally initiated signal is hold and HLDA. Hold and HLDA is used for DMA operation. DMA means direct memory access. In direct memory access, microprocessor can able to perform the operation. The memory of the microprocessor can able to perform the operation without the direct intervention of CPU. So we need a DMA controller. DMA controller, with the help of hold signal, it asks the microprocessor that I want to use your system bus for time being. Then upon receiving the request, microprocessor will send an HLDA signal to inform the DMA controller whether he is accepting that or not accepting that. If it accepts, then HLDA signal is high, then it will transfer the control of the system bus to the DMA controller. Upon receiving the system bus, DMA controller will perform the DMA operation between memory and IO. After the memory operation or IO operation is performed, DMA controller once again handed over the control of the system bus to the microprocessor. Next is reset in and reset out. It is an reset in bar. So you all know that it is an active low signal. When it goes low, program counter is set to 0, buses are tri-stated and MPU is reset. So with the help of resetting bar, basically the program counter is set to 0 and microprocessor unit or MPU is basically in the reset mode. And with the help of the reset out, what happens? The signal indicated by MPU or microprocessor unit will inform the rest of the unit that to reset the devices. For example, microprocessor may inform the memory or other devices to reset themselves. Our last category is serial input and output ports. When microprocessor needs to communicate with an input device, it uses SID or serial input port, SID or serial input data pin. With the help of that, any input device, for example keyboard or mouse, can able to send the data to microprocessor. Upon receiving the data, microprocessor will transmit the data through system bus and store it in memory or the registers in the microprocessor. Whenever microprocessor generates a result and the result is temporarily or primarily stored in the memory, it uses SOD or serial output data pin, and it transfers the data to some output device such as monitor or display device. Then it uses the SOD pin. Okay, this is basically all the pins related to microprocessor. We are observing now the pin description of Intel 8085 microprocessor. Next day we will start architecture of microprocessor. Now I would like to request you all to give the examination and your attendance through the link that I have provided to you. With the help of this link, now I don't think there is much problem regarding any buffer. There is no buffer problem, there is no audio problem or video problem or visibility problem. Okay. So is there any problem that you have faced? Is there any problem that you are faced? Okay, so now I would like to request you all to give the examination and give the attendance through the link that I have shared with you all. So I am ending my lecture here. Next day I shall deliver the lecture on architecture of microprocessor, and I shall share the PDF file of this portion that I have discussed today. So thank you all for joining the lecture.